Hi, boys and girls. Happy Wednesday. Today we're going to be working on Module 16, Lesson 3. So if you turn to your books to page 429, you can follow along with us. Our lesson is called Recognize and Generate Equivalent Fractions. Today's I-CAN objective reads, I can represent a fraction with equal parts that are smaller or larger in size than the equal parts of an equivalent fraction. And we're building on what we've been working on the last 2 days, boys and girls. We found equivalent fractions that have parts that are larger or parts that are less than. And remember, even though the parts or the numerator changes, it doesn't mean that the area that's being represented changes. And the reason for this is because when your denominator gets bigger, the parts get smaller, so you need more of them. Or if your denominator gets smaller, each part gets bigger, so you need less of them. So we're looking for fractions that name the same area or the same size or distance, but they look different. So today we're going to put it all together and we're going to find some equivalent fractions. Let's start off with a build understanding. Remember, boys and girls, it's important to do your 3 reads, even if I'm not doing all 3 reads with you. So Rico's band eats pizza after band practice each week. On Friday, the band eats 6/8 of a cheese pizza. The next week, the band eats the same amount of the same sized vegetable pizza cut into 4 equal pieces. What fraction of the vegetable pizza does the band eat? So if we were doing our first read, what is the situation about? What information is it giving us? Well, we know we're talking about pizza, and it's a band, and they eat pizza every week. And they're comparing the pizzas and how they were cut on 2 different weeks. And we know that each pizza is the same size. So now I'm going to read it again, but let's pay attention to the quantities. Rico's band eats pizza after band practice each week. On Friday, the band eats 6/8 of a cheese pizza. The next week, the band eats the same amount of a same-sized vegetable pizza cut into 4 equal pieces. What fraction of the vegetable pizza does the band eat? So I see 2 quantities in my problem just by looking at it. I see a fraction 6/8, and that fraction represents the amount of cheese pizza that they ate. And the next quantity that I see is the number 4. Now, the number 4 is not a fraction, but it's telling me that that's how many equal parts or equal pieces the pizza, the vegetable pizza was cut into. So then they got a vegetable pizza, and it was cut into 4 equal pieces. So if we're working with fractions and we know that one whole has 4 equal parts, which number in the fraction would we know? Well, we would know the denominator. Okay, so now let's go ahead and we're going to use the diagrams that the book gave us, and we're going to split these pizzas apart. And let's start with our cheese pizza that's already labeled. And we know that they ate 6/8. So before I can shade in 6 parts, I have to cut this pizza up into 8 equal parts. So I'm going to go ahead and cut a pizza as evenly as I can. Okay. And in another color, I'm going to shade in 6 of those parts. 1, 2, 3 parts out of 8, 4, 5 or 5/8, 6/8. So on the cheese pizza, the first week they ate 6/8 of the pizza. Now let's go to our vegetable pizza. So we know we have 4 equal pieces. So I'm going to go ahead and I'm going to split my pizza into 4 equal parts. The question is asking me, what fraction of the vegetable pizza does the band eat? Now we know they eat the same amount. So if they eat the same amount as the cheese pizza, how many of those parts do I have to shade in? Well, let's see what it looks like. I'm going to start off and I'm going to shade this part. Do those two amounts look the same? No, not yet. So I'm going to go ahead and shade another part. Do the amounts look the same now? Not yet. So let's shade in one more. What about now? Yeah, it looks like they ate the same amount of pizza. And just to be sure, I'm going to trace what they ate, outline it. Now I can really see that those two amounts are the same. So now let's find a fraction for how much of the second pizza, of the vegetable pizza they ate. Well, let's see. We know that our denominator is 4 because we broke that pizza up into 4 equal parts. And they had to eat 1, 2, 3 parts in order to eat the same amount as the 6 parts out of 8. So my fraction for the vegetable pizza would be 3/4. So now let's go through the questions. How can you draw lines to divide the two pizzas? Into how many pieces will you divide each pizza? Well, for the cheese pizza, we divided it into 8 parts, 8 equal parts. And then the vegetable pizza, we divided it into 4 equal parts. B, how can you shade the pizzas to show how much the band eats? Well, in the first one, boys and girls, they gave us the numerator, so that was pretty simple. We just went ahead and we shaded in 6 of those 8 parts. For the second one, we didn't know the numerator. We didn't know how many parts to shade in, so we had to make the shaded parts match the first one. And once they matched, we were able to count how many parts. C, what fraction can you write for the amount of each pizza that the band eats? Label each pizza to show the fraction of each pizza the band eats. How do these fractions compare? Well, we know that for the cheese, it was 6/8, and for the vegetable, it was 3/4. And how do they compare? Well, they're equal to each other. And what's that math vocabulary word that talks about equal fractions? That's right, equivalent fractions. So these fractions are equivalent fractions. And now we're going to go ahead and we're going to use our symbols to compare our fractions. So write the fraction, write greater than, less than, or equal to. The band eats blank of the vegetable pizza. Well, they eat 3/4 of the vegetable pizza. And if we want to compare 6/8 and 3/4, we're going to go ahead and do an equal sign to show that the fractions are equivalent. Okay? Now, boys and girls, take a look at the right, because even though my models were circles, you have the option of doing any of the models that we've learned about. So I'm going to show you 2 different ways that you can model this to help you. If you find that it's too hard to divide circles, you can always use bars or number lines. So let's start off with bars. Do you remember the important thing about when you're creating models that represent fractions? What do the holes need to look like? Well, they need to be the same size. So if you're going to draw your bars, you can go ahead and draw 2 bars and make sure that you line them up on top of each other so it's easier to see that they're the same size. And it's really important to label them. So this one is going to be my cheese and this one's going to be my vegetable. Okay, and I know that for my cheese, I'm breaking it up into 1/8. So I'm going to split it in half. Now, if I split 8 in half, that means that I want 4 parts on each side. Okay, and since it was 6/8, I know my numerator, so I'm going to go ahead and shade in 6/8, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. Now I'm going to move on to my vegetable pizza. And I didn't know the numerator, but I know that it's broken up into 4 equal parts. So if it's broken up into 4 equal parts, my denominator is going to be a 4, or I'm going to be counting by fourths. So again, I'm going to split it in half, and I'm going to use this top one to guide me. So I know half is right here, or the middle is right there. So I'm going to go ahead and draw it down the middle. And since I have a 4, I want to do 2 parts on the left and 2 parts on the right. Okay, and now I want to be able to shade in the same amount. So I want to go ahead and shade up to here. So I'm shading 1/4, 2/4, and 3/4. Okay, and if I shade in my 3/4, I'm shading in the same amount as 6/8. So both of those fractions are equivalent. And now I'm going to do a number line. Okay. I know that in the book, boys and girls, they show you one number line and you do one fraction on the top and one fraction on the bottom. But I've noticed that a lot of children get confused with those. So I'm going to go ahead and I'm going to do 2 separate number lines and I'm going to do them right above each other. And just like my bar models, I want to make sure that my number line, 1 whole, is the same amount. So that's going to represent 1 whole. And the second one is going to represent 1 whole. Okay, my first one is going to be my cheese. My second one is going to be my vegetable. It's really important to label your models so that you know what you're talking about. And my first one, I want to find 6/8. And then my second one, I know I want to find 4ths. I just don't know how many. So my top number line, I'm going to divide that into 8 equal parts. And I'm doing something similar to the bar model. So you should be noticing those similarities between a bar model and a number line. Don't let a number line scare you. It's the same thing as a bar model. So 8 equal parts. And remember, we're not counting the lines on a bar model. We're counting the spaces in between. We're counting those jumps. So now I'm going to go ahead and label it. And if I label it correctly, this last tick mark on my number line should be 8/8 or 1 whole. So I start with 0/8 or 0, and then each jump is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8, which is 1 whole. So I labeled my number line correctly. And now I'm going to go ahead and I'm going to label my second number line, and I want 4 equal parts. Okay, that looks about right. And now let's see if I labeled it correctly. We're going to start with 0 or 0/4. The first jump is 1/4, then 2/4, 3/4, and finally 4/4. So I know my number line is labeled correctly because I end with 4/4, which I know equals 1 whole. So let me get another color. Okay, and I know that my cheese pizza, they ate 6/8. So 1, 2, 3, 4, 5, 6. So they ate 6/8 of a cheese pizza. And I want to find the same amount. So if I look at it vertically, I can see that the same amount would be right here. So 3/4 would be the same thing as 6/8. So those are just some extra models, boys and girls. You can use whatever you're comfortable with. I like to introduce you to a lot of different ways, but whichever one you feel comfortable with, please go ahead and use it. So boys and girls, today we're not going to do the on your own. We're actually going to solve an extended response problem. And you know that when we learn new skills, I like to give you problems, real world problems, that help you to figure out when you'll actually use this. So today we're going to be using fractions or equivalent fractions using recipes. Now recipes, you can always find fractions in recipes. So let me do the first read, and I want you to think about what the situation's about. Sandra is teaching Monica how to make tres leches cake. The recipe calls for 1/2 cup of sugar. Monica says she can't make her cake because she only has a 1/4 cup measuring cup. How can Monica use her 1/4 cup measuring cup to find the exact amount of sugar needed for the cake? Prove your answer by drawing a bar model or number line. So what is the situation about? Well, Sandra knows how to make tres leches cake, and she's teaching Monica. And we know that the cake needs at least one ingredient, which is sugar. And Monica's having a problem because she doesn't have the right tools. She doesn't have a measuring cup that measures a half a cup. Okay. Now I'm going to go ahead and I'm going to read it again, and I want you to pay attention to the quantities. Sandra is teaching Monica how to make a tres leches cake. The recipe calls for a half cup of sugar. Monica says she can't make her cake because she only has a quarter cup measuring cup. How can Monica use her quarter cup measuring cup to find the exact amount of sugar needed for the cake? Prove your answer by drawing a bar model or a number line. Okay, so on the left, I see my sugar, I see my recipe, and I see the quarter cup that Monica has. She doesn't have a measuring cup that measures a half a cup, so we have to help her to see what she can do. So boys and girls, it is your turn. You're going to pause this video, and I want you to either draw a bar model or a number line or any other model that you feel comfortable with. And I want you to solve Monica's problem. We want to help her. How can we help Monica so that she can bake the cake with the right amount of sugar? So you're going to pause. Once you're done, I want you to come back to the video and we'll go over it. All right, boys and girls, welcome back. Was anybody able to help Monica bake her cake? Well, let's take a look. I feel really comfortable using bar models or fraction bars. So I'm going to go ahead and I'm going to draw a fraction bar. And my fraction bar is going to represent 1 whole cup. Okay? And I'm going to draw another one. Now, my first bar, I'm going to divide into 2 equal parts because that's the amount of sugar that I want or that I need for the cake. I need 1/2 cup. So sugar needed. I need that much sugar. I need 1/2 of a cup of sugar. But Monica does not have a measuring cup that measures that. Her measuring cup is 1/4. That means it would take 4 equal parts to make 1 whole cup. So I'm going to go ahead and break this one into 4 equal parts. Let me make that another color. Okay. Now, how many of those parts would I have to shade in order to get the same amount of sugar? That's right, 2. If I shade in just 1/4 or 1 part out of 4, I don't have enough sugar for the cake. So if I go ahead and I shade in another part, so 2 parts out of 4 or 2/4, I have the same amount of sugar as the cake is asking for, which is 1/2. So that bar model helps me, but I still need to explain to Monica what she can do in order to get the correct amount of sugar. So if I need 2/4, what can I do with that measuring cup? Well, I would tell Monica, measure 1/4 of sugar, cup of sugar, put it in a bowl, and then measure another 1/4 cup of sugar. So she would have to fill up her quarter cup 2 times in order to get the same amount as a 1/2 cup of sugar. Okay? Oh, look at that, boys and girls. It is our code word for today, and I'm going to erase this so you can see it. Today's code word is monster. Make sure you write it down so that you know it when you get to your Nearpod activity. As you're writing it down, I have an exciting new activity for you today on Nearpod. So when you get to it, I want you to take your time and have a little fun with it. The activity that I put on is an equivalent fraction simulator. When you go on, boys and girls, you're going to be able to change the denominators and the numerators, and the computer is going to show you an equivalent fraction. They also show you a model to go along with it. Okay, I'm going to try and record myself using it, and I'm going to try and put it in tomorrow's lesson. A few things that I want you to notice. When you have two fractions, as you change one number, boys and girls, let's say you change, you make it a denominator of 2, you're going to notice that the computer changes it to a 4. You're also able to increase that second denominator, and the computer is going to change it to a 6. If you increase it again, the computer is going to change it to an 8. I want you to look for relationships between the denominators. What relationships do you see? Do you see any patterns? If it's a 3, the computer is going to give you an equivalent denominator of a 6. If you increase this one, it's going to turn it into a 9. So I want you to start looking for patterns and see if you're able to think of an equivalent fraction without even doing a model. Okay, and that's later on, boys and girls, but I do want you to be aware that there are certain patterns that you're going to be able to see and explain in equivalent fractions. All right. So, boys and girls, the Nearpod codes for today in English: G, S, R, F, Q. En español, N, R, A, D, Y. E em português, o código KFLNB. So boys and girls, take your time with that. Enjoy that equivalent fraction simulator, and I'll see you tomorrow. Reach out to me if you have any questions, and don't forget to subscribe and like my video. Bye, boys and girls.